Good day everyone, this is Cheezel, and in this video we will be discussing about the conic section hyperbola. So let's say if we have x squared over 9 minus y squared over 4 equals 1. The general equation of the hyperbola it's x minus h squared over a squared minus y minus k squared over b squared is equals to 1. Now, a is not a larger of these two. This time, a squared is simply whichever comes first. You can also have the other form of these equations, which is y minus h squared over a squared minus x minus h squared over b equals 1. So, whichever one is positive is associated with a whatever one is in front of the negative sign or whichever one is negative. Has the b squared. Now, we need to realize that for a hyperbola, if x squared comes first, it's open left and right. If y squared comes first, it's open up and down. But we'll go over a few examples, so let's solve this one. The center is 0, 0, because there's no h and k for the example. So that's where that's the midpoint of the two verticals. Since a is 3, we need to go 3 to the left and 3 to the right. And b squared isn't 4, so that means b is 2. So we need to go up 2 and down 2. And then make a box. In this case, that these two lines crosses the makes sure it forms like a diamond.
Crosses the make sure it forms like a diagonal through the rectangle. It has to pass through the center as well. Now, these 2 points are where the graph is actually going to touch. It's going to meet at those 2 points. It doesn't touch these 2 points here. Those are imaginary points. So this graph is going to look like this. It follows the asymptote, it touches the vertex, and then it follows the other asymptote. So that's how you graph a hyperbola. These are called the vertices. Those are the vertex of the hyperbola. So the vertices are plus or minus 3, 0. The foci is somewhere here. It's always where the graph opens towards. So if the graph opens this way, the foci is like towards it. If it opens this way, the foci is over here. Now to find it, it's a little different. Instead of it's c squared equals a squared, not minus, but plus b squared. For an ellipse, it's a squared minus b squared. This time, as you can see, the value of c is larger than the value of a. So that's why c squared is a squared plus b squared. So it's going to be 9 plus 4. That's 13, so c is the square root of 13. So the foci, therefore, is plus or minus radical 13, 0. Now the only other thing that we need to do for this type of graph is we need to find the asymptotes. The equation for the asymptotes, it's y minus k is equal to, now it can be b over a or a over b, plus or minus. And then x minus h. Here's how you tell. So what we have is the asymptote is basically a line. And whenever you have a linear equation, in slope-intercept form, it's mx plus b. Notice that the letter in front of x is m, which represents a slope. So b over a is the slope of the line, which is rise over run. So from the center to this point, you need to go up b units, that's your rise, and then you run a units. So it's a rise over run, b over a. for this particular example. When it opens this way, it's actually going to be a over b. But you can tell by just doing rise over run. So for this actual equation, we know that h and k are 0. So to write the asymptotes, it's going to be in form, it's mx plus b. Notice that the letter in front of x is m, which represents a slope. So b over a is the slope of the line, which is rise over run. So from the center to this point, you need to go up b units, that's your rise, and then you run a units. So it's rise over run, b over a, for this particular example. When it opens this way, it's actually going to be a over b. But you can tell by just doing rise over run. So for this actual equation, we know that h and k are 0. So to write the asymptotes, it's going to be just y, there's no k, is equal to plus or minus the value of b, which is b is 2. B squared is 4, so b is 2. And a, if a squared is 9, a is 3. So it's y is equal to plus or minus 2/3 x. Those are the asymptotes for this particular hyperbola. So let's try another example.